this question says find the derivative of y equals x squared minus 1 to the 6th power. We're going to use the chain rule to find the derivative of this function because we have an inside function, which is x squared minus 1, and an outside function, which is the 6th power. Our inside function is something other than x, so that means that we have to do the chain rule. So the chain rule says the following. This is the chain rule, where you have one function inside of another function. It's called composition. And the way you calculate the derivative using this rule is that you're going to take the derivative on the outside function. You're going to evaluate that at the inside function, and then you're going to multiply by the derivative of the inside function. So for this example, the 6th power is our outside function, so we want to follow the power rule when calculating the derivative of the outside function. With the power rule, when you're calculating the derivative of x to a power, you're going to multiply by that power and then subtract 1 from the power. So that's what we'll do here. For our outside derivative, we'll multiply by the power and subtract 1 from the power. Then we're going to evaluate this at the inside function and then multiply by the derivative of the inside function. This gives me 6 times x squared minus 1 to the 5th. The derivative of x squared is 2x, and the derivative of 1 is 0. And then we can simplify this to be 12x times x squared minus 1 to the 5th. And this is our derivative. We want to find the derivative of e to the x squared minus 7. And we're going to use the chain rule on this. And we're going to use the chain rule because in the exponent, we have something other than x. So in the exponent, which is on the inside, is x squared minus 7. And then on the outside is this exponential e. So when we calculate the derivative, we're going to follow the derivative rule for the outside function, and that is that the derivative of e to the x is e to the x. So the derivative rule for the outside function is meaning that it's going to stay the same. So we still have e, and we leave the inside the same, and then we need to multiply by the derivative of the inside. And that would give me e to the x squared minus 7, and the derivative of x squared minus 7 is 2x. So I would write that derivative as 2x e to the x squared minus 7. So this should be a minus 7 here. So on this question, we want to find the derivative of e to the 7x minus 2. And once again, we're going to use the chain rule. And with the chain rule, let me show you what the chain rule looks like. The chain rule is for calculating the derivative when you have one function substituted inside of another function. So in this way of writing it, we write f of x, f of g of x. So we're saying that the function g of x is substituted inside the function f of x. And the way we calculate the derivative with the chain rule is that we are going to take the derivative on the outside function. We leave the inside function alone, and then we multiply by the derivative of the inside, and that's the part that we call chaining. Chaining is multiplying by the derivative of the inside. So for us to calculate the derivative of this e to the 7x minus 2, I need to identify what the inside function and the outside function are. So what I can see is that in the exponent I have 7x minus 2, and it's in the exponent of this e here. So what I'm going to think of is that f of x, my outside function, would be e to the x, and g of x, my inside function, is 7x minus 2. So if I were to write f of g of x, that's substituting g of x inside of f of x, then I'm taking this x squared, sorry, that's a 7x minus 2, and I would substitute it in for that x. And that's how I get e to the 7x minus 2. So that's my inside function of g of x and my outside function of e to the x. And then when I calculate the derivative, I'm going to follow the rule for the outside function first. So the outside function in this case is the e to the x. So the rule for the derivative of e to the x is e to the x. So if I'm following that rule, that's saying that it stays the same. And then I need to multiply by the derivative of the inside. So that's multiplying by g prime. So I want to multiply by the derivative of what's in the exponent. And the derivative of 7x is 7. The derivative of 2 is 0. And so we get 7e to the 7x minus 2 as the derivative. On this question, it's asking us to calculate the second derivative. So looking at these symbols, we have d squared. That means to take the derivative twice. We're going to take the derivative of y, so that's this equation here, and both times we calculate the derivative, we're going to take the derivative with respect to x. So first we need to calculate dy dx, that's the first derivative. And to calculate the first derivative, we're going to use the product rule in this example because this is x times e to the x. Both factors have a variable, so that's why we're going to use the product rule. Now with the product rule, that's when you have one function multiplied by another function. We'll say f of x times g of x. And the way you calculate the derivative with a product is you're going to do the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. So we're going to follow the product rule to calculate the derivative, and we'll use x as my first factor and e to the x as my second factor. So that's the first times the derivative of the second plus the second times the derivative of the first. This is going to give me x. The derivative of e to the x is e to the x. The derivative of x is 1. So we have the first derivative being x e to the x plus e to the x. And now we can calculate the second derivative. So we're taking the derivative the second time, again with respect to x. And I want to calculate the derivative on this right here. On this piece, this first term, we need to use the product rule to calculate the derivative. because we have two factors and both factors have a variable in it. So we'll do the first times the derivative of the second plus the second times the derivative of the first. And then we want to calculate the derivative of e to the x, which is e to the x. This is x. The derivative of e to the x is e to the x. The derivative of x is 1. We have x e to the x plus e to the x plus e to the x. And I can combine like terms to get x e to the x plus 2 e to the x.